Hey folks, so this is section 4.5d, the fourth video in section 4.5. So let's go ahead and take a look at this next example. It says that we should find f. Well, we already know f means the original function when I've been given the first derivative, whose graph passes through the given point. So quite frankly, folks, we've actually done a couple of questions already like this. The directions were worded a little bit differently, but other than that, we've pretty much done the same thing. First thing I want to do is I want to write it properly. So if I want to find f of x, I'm going to use the integral of the derivative. Don't forget your dx. So I'm going to let u be the inside. That's going to be 2x. So the derivative is 2. I'll multiply on both sides by dx. It doesn't look like I'm going to need that 2 though, so I'm going to move it to the left side. All right, now let's start our substitution. So for our substitution, to take care of all this piece, I'm just going to write in secant squared of u. And then the only thing that's left over after that is the dx part, so I'm going to replace that with a 1/2 du. 1/2, constant multiplier, we like to write it out front. So we've got our 1/2. The integral of secant squared is tangent. Don't forget your constant. And then let's go back and put our x's back in. So we have 1/2, the tangent of 2x plus c. Now, this would be the end of this if we were simply asked for the indefinite integral, but we weren't. We were asked to find the original function. So let's take this to the next step then. Let's use the coordinate that we were given to figure out the rest of the function. So we want to find f of pi over 2 using the x that we were given. We're going to plug in that x. So that's going to be 1/2 tangent of 2 times pi over 2 plus c. And then that's going to equal 2 because that was the y value of the coordinate we were handed. All right, continuing on then, clean that up. We've got 1/2 tangent of pi plus c is equal to 2. Tangent of pi, if you use your unit circle trigonometric values, you can see that I've drawn where pi is. Tangent is sine over cosine, so that's going to be 0 over 1, which is just 0. So 1/2 times 0 plus c equals 2, so therefore c equals 2. I now have all the pieces that I need to be able to find the original function, and the original function will be 1/2 tangent of 2x plus 2. All right, let's do another one of those. So again, the very first thing we want to do is we want to write it correctly. So our original function is going to be the integral of the derivative. Don't forget your dx. We'll go ahead and find our u, which is going to be on the inside. The derivative of that will be negative 2x. Get your dx to the other side. Notice I didn't move anything because I actually wanted a 2x and a dx, and so I had all of that. So both of those are going to get replaced with du. The only thing that's left over to get replaced is the 8 minus x squared to the 1/2 power, so that's going to be u to the 1/2 power. The integral is going to be 2/3 u to the 3/2. Don't forget your constant. And then let's replug back in. So we have our 2/3 to the 8 minus x squared raised to the 3/2 power plus our constant. This would be the end of the question if all we were asked for was the indefinite integral. But we're actually asked for the original function f of x. So let's take it a step further, and we're going to use this coordinate to help us out. X value 2, y value 7. So we want to find f of 2. So let's go plug in a 2 for all of the x values plus c, and that's going to equal the y value of 7. So we'll do the work then. Notice that I used that 3/2 power. I thought of that as a square root cubed. And so that's going to give me a c value of 5/3. Now I have enough to go ahead and write my original function. So that'll be f of x is equal to 2/3 quantity 8 minus x squared to the 3/2 power plus the c value, which was 5/3. All right, the next question is just to simply find the indefinite integral. Okay, so the inside then is going to be my 3x minus 4. The derivative is 3. So du will equal 3 dx, but I don't have any 3's, so I'm just going to have a 1/3 du dx. Now, the problem here, and we are going to run into a couple of problems, so let's take a look at what this problem is. So right now I have something that I can replace the 3x minus 4 with. I'm going to replace that with a u. So let's go ahead and put that in first, the u to the 1/2. I also have something that I can replace the dx with. The dx is going to get replaced with a 1/3 du, so we can go ahead and do that. The problem is that I have nothing to replace the x with. And remember, you cannot write this with any x's. It needs to be completely written with nothing but u's and du's. So what I'm going to do here is I'm going to take this original u equation that we created, and let's just solve for x. Let's get x alone. So we want to take u equals 3x minus 4. Let's solve for x. So it's going to be 1/3 quantity u plus 4. Adding 4 to both sides, dividing by 3 on both sides. Oops, sorry about that. So now that x can be substituted with 1/3 u plus 4 quantity. And so that's going to be the third part of that. Now, that red 1/3, the one inside the integral, let's go ahead and take it out to the front, that'll make a 1/9 when combined with the other 1/3. And then we can distribute the u to the 1/2. And so that'll make a u to the 3/2 plus a 4u to the 1/2 du. And then I can integrate both pieces because there's just two terms there. So the integral of the first term is going to be 2/5 u to the 5/2. And the integral of the second term will be 2/3 u to the 3/2. And then don't forget there's already a 4 out there. Don't forget your constant. All right, so then let's just clean this up and we'll be finished. One of the things that I did here is that I went ahead and distributed the 1/9 to the two terms. So I'm going to have 2/45, so that's going to be these two pieces multiplied together, times u, but instead of a u, now I'm going to have my 3x minus 4 raised to the 5/2. And then the 1/9 times the 8/3 is going to end up being 8/27 times my u, which is now 3x minus 4, raised to the 3/2 plus c. There is another way that you can write this. Because these are fractional powers, these can both be written as square roots. So this guy can be written as a square root to the 5th power, and this guy can be written as a square root to the 3rd power. So I did want to just show you that to show you what it would look like if that's what you chose to do. And I'm fine with either one of those. All right, let's look at number 56, which is very similar. So the first thing, we've got our u, which is 2 minus x. The derivative of that is -1. Multiply on both sides by dx. And we're going to have negative dx, but then I moved that negative to the other side simply because it doesn't look like I'm going to need it. Okay, so now let's start our substitution. So I have something to substitute for the 2 minus x. That's going to be a square root of u. And you'll see that right here. There's my u to the 1/2. And I also have something to plug in for dx. Dx is going to get replaced with a negative du. But what I don't have anything to plug in for x plus 1. So let's do something like what we did on the last question. Let's take our u equals 2 minus x, and let's solve for x. So when you get x alone, that's going to be x equals 2 minus u. So then what I can do is the x can be replaced with a 2 minus u. Just don't forget that you still have a plus 1 there. Okay, so there's my 2 minus u in for the x, but then there's the plus 1 that was already there that I haven't touched. All right, now let's start cleaning this up so that we can integrate. I've got my negative out front. The first quantity is going to get cleaned up to a 3 minus u. And then the other two I'm just going to copy. Continuing to clean up, this time let's go ahead and distribute the u to the 1/2 to these two terms. So I still have my negative. And the first term is going to be 3u to the 1/2. My second term, negative u to the 3/2 du. And then we can integrate. So the integral of the first term is going to be 2/3 u to the 3/2. Just don't forget the 3 in front of that. Minus the integral of the second term is going to be 2/5 u to the 5/2. Don't forget your constant. Continuing to clean up, and not only are we going to clean up, but we're also going to plug our u back in, or our x's back in, that 2 minus x. So let's go ahead and do that. So the 3's will cancel out of that first term, and I'll have a negative 2 times my u, which is 2 minus x, to the 3/2. Just don't forget that you need to take this negative and distribute it to both terms. So that's why that second term is positive. 2/5 times my u, which is now 2 minus x, to the 5/2 power. Again, because these are fractional powers, I can rewrite those as square roots. Those are going to be especially effective when I'm evaluating, when it's a definite integral. So that's why I continue to show you that. All right, let's do one more example of those. So on this one, let's make our u x plus 4. du is just going to be 1. Multiply on both sides, so du equals dx. Now, so far, I do have something to plug in for the denominator, and I have something to plug in for dx. I don't have anything to plug in for this x, and that's a problem. So then let's go ahead and continue by cleaning up, and again, that's taking this original u equation and solving it to get x alone. And now, once I have x alone, I've got something that I can sub in for everything. Okay, so the first thing, let's get our u taken care of. So that's going to be a u to the 1/2 written up on top. dx is going to become du. And then the numerator, the 2x plus 1, the only thing that's getting substituted is the x piece of that. So notice I've got a 2x plus 1, but instead of the x, I've written the u minus 4. All right, let's clean up our integral. So that'll be a 2u minus an 8 plus a 1 times u to the negative 1/2 times du. And then again, we can distribute. So when we distribute, you're going to get 2u to the 1/2 power minus 7u to the negative 1/2 power du. We can integrate. So that'll be 2/3 u to the 3/2 for the first term, and 2u to the 1/2 for the second term, plus c. Let's clean up the numbers out in the front, and let's sub back in x plus 4 for our u's. So you have 4/3 times our u, which is x plus 4 to the 3/2, minus 14 x plus 4 to the 1/2 plus c. Once again, they're fractional powers, so I can go ahead and rewrite those as square roots at the end, and that would be just fine.